Wait, you might want mine too.
Okay, folks, 10-6. Tangent, secants, angle measures. Here we go. I'm going to review. Go to this little box and put some stuff down in this corner. Okay, are you guys all where I am? Down over here in this corner where there's some little lines, I'm going to draw some review stuff. So here we go. Put a circle. Okay, and let's say I'm going to put the dot in the center of the circle. Let's do this. Let's say we've got a, how big does that angle look? 60? Sure, we'll say 60 degrees. Okay, so there is that. How big is the arc? What's the measure of the arc? Also 60 degrees, okay? Let's say instead now I take and pull him all the way back. What's the measure of this angle now? 30, because it's half, right? Okay, do we remember this? Yep. Okay, now we're going to start talking about, last section we talked about tangent lines, okay? Do you know what a tangent line is? Yeah. Okay, so like let's say I have the radius of the circle right here, and a tangent line is like this guy here. What's special about the radius and the tangent line? It makes a 90-degree angle, right? Okay, so sometimes they'll do this to you, and then they'll make a right triangle, and you can do the Pythagorean theorem and all that stuff. Ready? Okay, so here we go. Now we're talking about secant lines. A secant line is a line that touches the circle in two places. So you see this line right here? He's touching there and there. And this line right here is touching there and there, right? Okay, and they are intersecting inside of the circle. Okay, are you ready? This arc is 55 degrees. This arc is 75 degrees. They are different from one another, right? Like they're not the same. So what happens is, let's talk about like this angle versus this angle, those two little green angles. What do we know about the two green angles? They're vertical angles. They will be the same measure, but are they 55 or are they 75? What are they? They're the average between the two. So I take 55 and I average 75, so I add them together and divide by 2. What's the average of 55 and 75? You maybe know this. 65, it's halfway between, right? So this angle here is 65, this angle here is 65, but that's not what they want. They want angle X, right? Okay, so I'm looking at like this line right here, this blue line. Okay, you're going to go to the office if you don't stop and be quiet and pay attention. Okay. This is not very long that I'm teaching. Focus for that amount of time. Okay, this blue line that's going across here is 180 degrees. So if we just said that that was 65, the other one is? 115. 115, yeah? Okay, so the two little arcs on the side, we have to average them together to figure out what the angles in the middle are. And then if they want the top angle or the bottom angle, we have to subtract, right? Okay, all right, let's do this one. Okay, so this little arc right here is 47. I'm on the check at the top of the next page, at the top of 610. Okay, that is 47 degrees. This is 116 degrees, and they want this angle right here. I know that that green angle and this green angle are the same because they're vertical angles, but it will be the average of the two. I take 116 and 47, and I add them together. 47 and divide by 2, and it is what? 81.5. 81.5? 81.5. Okay, is that what X is or is that not what X is? That is what X is. 81.5 is what they are wanting. So each one of those angles is 81.5. Now, what if they asked for this one right here? This is a straight line. You subtract from 180, it would be like 99.5 or 98.5, whatever that is, right? 98.5 is what he would be, right? Okay, so we can figure out those. So when you have two angles that are crossing, or two lines that are crossing in the middle, to find those angles, you have to average what the arcs are. Got it? Okay, now let's say we have this going on where we have a tangent line. This is a tangent line. How do I know it's a tangent line? What's a tangent line? It only crosses at 1 point. A secant line crosses at 2 points. So now I have a secant line and a tangent line that are coming together. And this angle right here is 116. This angle right here would be 64 degrees. What is this arc versus this arc? You know what? This is exactly similar to when I have this going on, where I had 30 degrees and 60 degrees. If it's all the way across the circle, the arc is half, or the angle is half of what the arc is, right? So if this angle is 64, what's this arc right here? 128, right? Because, okay, because look at this. A circle has how many degrees in it? 360. A line has how many degrees in it? Half of that, right? So if this is 64, that's 128. If this is 116, what's this one?
232.
232, right? It's kind of similar to how we have it over here. It's all the way across the circle, so that arc is going to be twice what the angle is, right? Okay? What do you mean? Okay, so take a look at the vertex right here. The vertex is on the edge of the circle, right? So it's like the double thing. If it's on the edge of the circle. Now, here, the vertex where those two lines were crossing is inside of the circle, right? So I have to average them together to figure out what those angles are. Does that make sense? Okay. Now, we're going to see the third scenario where I have two lines. What is this line right here? Is that a secant line or a tangent line?
Oh, no.
This top line right here is a tangent line, and this one right here is also a tangent line. All right, we're going to have this happen, okay? Let me draw this off to the side over here. Let's say, so we just had the scenario of where this happens, right? And whatever this angle is, this guy is double that, right? We had this scenario happen where we have two lines cross each other, and those angles are going to be the average of these two together, right? You add them and divide by 2. You add and divide by 2. Here you just divide by 2, right? I just divided by 2. Here I add and divide by 2. Let's say I have this scenario happening where I have this going on, okay? Where they're intersecting and the vertex, so Jace was just asking, the vertex is outside of the circle. Let's say they give me that this is 100 degrees and this is 50 degrees. How big is this angle right here?
25.
How?
I don't know. It just feels like that would be the answer.
Here we divided by 2. Here we added and divided by 2. Here we
Divide by
subtract and divide by 2. So if I take 100 and I subtract 50 and I divide by 2, it's 25, like you said, right? Right? Okay? So if they're intersecting outside of the circle, like this one is, you subtract those two arcs and divide by 2. If they're intersecting inside the circle, you add the two arcs and divide by 2. You're taking the average. Here, if it's on the edge of the circle, you're just dividing that amount by 2. Got it? That's it. Those 3 rules. Okay? Let's go to, do we have anything else besides that one? Okay. All right. We haven't figured this one out. So they give me that this angle is 36. This is hard. This is a hard one. I know that what I just told you is whatever this arc is and whatever this arc is, I subtract those two and I divide by 2 and that gives me 36. Okay, so we got to think about this a little bit. This pink arc right here and this blue arc, are they necessarily the same? No. But what do they add up to be?
360.
360. Okay, let's call this guy X right here. So the pink guy would be what?
2x.
Not necessarily double that.
Half x. No.
Let's say if X is 100 degrees, what would this one be?
100 or 200.
260. How'd you get that?
Subtract from 360.
Oh, no.
360 minus X. So this arc is 360 minus X. This small arc is just X. Got it? 360 minus X and X, right? Okay. Now, what do I do with the pink one and the blue one to get 36?
Subtract.
You subtract. So which one do I subtract? Which one do I start with? This one minus this one divided by 2 equals 36.
The bigger one minus the smaller.
360 minus X minus the other X, right? This arc minus this arc divided by 2 gives me 36, yeah? Okay, this is kind of weird. What's this top simplified to be? 360 minus 2x. Okay, I want to get rid of this 2. So I'm going to multiply the 2 over. You see what I just did? I get rid of the 2. Okay, what's 36 times 2?
6 times 12.
72?
7.
36 times 2. Do you see what I just did?
Yeah, 72.
Okay. So the big arc minus the small arc, that ends up being 360 minus 2x. I'm going to get rid of this 2 by multiplying the 2 to the other side. So they cancel here, and that's 72. Yeah? Yeah? Okay, now I'm trying to solve for x.
Add the 2x over and minus the 7.
I'm going to just subtract the 360.
I don't like it.
So we get negative numbers. It's fine. Negative 2x equals, what's 72 minus 360? Negative 2. I don't know. 2, 8, I don't know. 360
288.
288. Okay, and then what? divided by negative 2. What's 288 divided by negative 2? 144. So this arc right here, this smaller one right here is 144. What's the other one? 360. 216. Okay, does that make sense? Now, if you take 216 and you subtract 144 and you divide by 2, will you end up getting 36? Probably. Okay? So that's how we do that when we don't have labels on either one of them. I know that this arc and this arc make 360. So let's label one of them x and the other one 360 minus x, right? You're going to want to come back to this example, example 3, when you do problems like that, like, I don't know, number 15. Number 15 is exactly like that. Okay? All right, so let's take a look at these. I'm going to go through example 1 through 16 all, by the way, is the homework. Okay? Let's take a look at 1, 2, and 3. Okay, take a look at 1, 2, and 3. Let's figure out like a strategy here. Number 1, number 2, number 3, they are all kind of set up similar to each other, right? They are crossing inside of the circle. So what's the strategy? What's like the formula thing? You add them and divide by 2. You average them, right? So I add and divide by 2. What am I adding? These little arcs. 30 and 55, I add them and divide by 2. Got it? 40 and 52, I add them and divide by 2. 28 and whatever this guy is, let's call him x, and I divide by 2, and that's equal to 45, right? So like if they give you this 45, I'm going to add 28 plus x together. Let's just call him x, right? Divided by 2 gives me 45. And then we work backwards, right? What are you going to do first? Times the 2. So 28 plus x gives you 90. And then you subtract the 28, right? Okay. So you can label him as x if you want to. All right. What about 4, 5, 6? What's the strategy there? I'm adding and dividing by 2 again, right? Add and divide by 2. Right? Because they're intersecting inside the circle, right? Okay. Now 7, 8, and 9, they're intersecting on the edge of the circle. So what do I do there? I just divide this thing by 2. So if this is 168, I divide him by 2, and that will give me that guy, right? I'm just dividing that by 2. Same thing with 8 and 9. What about 10, 11, 12? I'm just dividing by 2. Now, how do I do 6 over here? Like they give me that this is 160. Yeah, so if this is 160, then this is how much? 200. So then how much is angle 6? 100. There you go. Okay, so you sometimes might have to find that extra step first, right? Okay, but those are just divide by 2, okay? 13, 14, 15, that is where you, because they're intersecting outside of the circle. So you are subtracting, then divide by 2. So I am taking 120, I am subtracting 40, and I am dividing by 2 to get whatever that angle is, right? I am taking this guy. Ooh, they don't give you what that guy is. I know that this is 60, but how do I figure out what this big arc is? What do all 3 of these chunks add up together to be? So this is 60 and this is 144. What's this guy? 156. There you go. That's what that pink arc is. And now can you subtract and divide by 2 to get him? Okay. So some of these you might have to, like 15 is going to be exactly like example 3. So take a look at example 3 to do number 15. That one's going to be tricky. You can label this guy as 360 minus x, and you can label this guy as just x if you want to, and then do the whole problem again. Okay? All right? So you're either adding, dividing by 2, you're subtracting and dividing by 2, or you're just dividing by 2. Got it? Depending on where it intersects. Inside the circle, outside the circle, on the edge of the circle. Got it? Okay, that's fine. I'll take it. Scroll up to example 3. Okay. Okay. I will leave it there.
Can you go back to the thing where you explain what you do on each one?
Sure. I'm going to stop the video. Okay, goodbye, people.